Alright, welcome back to the stream, folks. It is a sunny, warm Sunday here. My cat is melting on the chair. He is so flat. pulse audio might be broken on my system.
Effective safety min. Effective safety min. Effective safety min.
The CSBI.
Through our investigation.
Commission and independent. Commission and independent.
Companies should evaluate.
I should have known better than to mention any particular software by name in a disparaging way, though, because then inevitably people want to blame that software when I'm the one doing ridiculous things with it. Anyway, hello.
Get this in.
So remember my duty. So remember my duty.
Welcome back to my
Like nudity.
wonderful on
So starting to do some interesting things. I had a couple of things to do on my list here to make it a little nicer, I guess. I recently added this knob, which is not yet hooked up. Wanted to add some random variability to the timing of the individual grains. I need to write a little bit of infrastructure in the synthesizer to make that work. But that seems like it would... You know, there are a lot of cases where it's making a sound that's pretty good, except that the repetition of the grain period itself is really taking over all the other sounds. And so if I could add a little bit of like spread spectrum modulation to that, it seems like it would open up some new possibilities. So that's something I want to try maybe on the stream. I left off kind of without really any plan to implement this waveform display. And you can see I've got something here. It's got a variable scale like I was talking about. Normally it looks fixed though, so it's tries to be intuitive-ish and match the width of the file that you have loaded. But it's got some edge cases where, you know, if you're playing a bunch of different sounds from different files or with different speeds, then it all has to display those in the same graph, and so you might end up with a scale that's actually the combination of whatever's playing and the current settings that you have loaded.
And enjoy all the way.
I love wrecking things.
Follow next on your station for cartoons and fun.
To recognize the signs.
To recognize the signs. Alone. How
So it's doing some interesting things. I want to hook up that rate spread knob. I've got this graph that kind of shows this horizontal timeline that I want. I feel like the horizontal component of this graph is basically operating how I want it to. It's got I've been trying to fight flicker this whole time though. Like this is, this started out as just a display of a bunch of discrete vertical playback positions. It's just that gets messy really quickly once you start playing enough grains that it starts to get similar to the like the pixel resolution of your screen. Then it seems like you really want something more like an analog kind of coverage map. So this is an attempt at calculating something which is basically a screen resolution rather than sample resolution map of what parts of the waveforms are being played, multiplied by the gains of each individual playback. So it's just a single file or a single buffer for the entire window. It's not per wave right now, but you can see, let me turn this off so I can talk over it. Oh, actually, that won't work because this is showing the gains rather than the velocities. Just mute the channel. So yeah, if I set this up to give me a pretty wide MIDI dynamic range, so now I can have very quiet keys and louder keys, and you can actually see those as different brightnesses on this graph. I can just spew out grains really quickly, and when they're too quick to actually show on the graph, they don't flicker, they just blend together nicely. So that took a couple of filtering steps, but it's still not quite right. It's got like an automatic gain control filter that's kind of flickering out some of it, but you're seeing this artifact where some of the frames are just on average brighter than some of the other frames. I think that's coming from a couple of sources, but mostly it's because this is collecting data on these like video frame sized chunks of time, and then inside those video frames there could be a variable number of different audio processing frames, and so we have to have something that looks consistent even though a different amount of data has been collected. Anyway, I was fussing with it, and I have a technique that kind of works, but I'm not really happy with it because it still kind of flickers. I was thinking that I need to move from doing this pixel resolution approach to something which is actually audio sample resolution. So then I would effectively be calculating like an audio sample resolution coverage map of the waveform, and then resampling that to the width of the image for every frame. I don't know if I don't know, it's kind of a large amount of extra processing though, and I'm stuck doing that in the audio thread. So then I started to think about this other change that I might want to make that could overlap with this design, where I think I do actually want to show all the different waves separately. So right now, if you have one thing that's completely repetitive versus if you have a bunch of things that are all a little different, like you don't actually see those distinctly on this graph. So like, for example, it would be nice if I'm just holding down one grain, this is actually just the same waveform that's being looped in one little piece. So it would sound really repetitive. And if I was graphing this per waveform, it would also look really repetitive. It would just be a single like horizontal line. Whereas if I had one of the spread features turned on, like the selector spread or the pitch spread, and I was playing a MIDI note, then now I'm just playing grains from all over the place. So this has actually probably already got dozens or maybe even like 100 concurrent waveforms happening. And so it'd be nice to also be able to visualize like how many different things are playing at the same time, how many different places on the same thing are playing. So I think I want to start by just taking this existing graph concept, but splitting the y-axis so that it's per waveform. So if you're playing just a single thing, it would look basically like this. But if you're playing I'm not playing a single thing right now. If I actually demonstrate that, if I just click on one grain and play that grain, these would all look basically the same. But then if I start playing a big spray of grains or some complicated MIDI is coming in, then you would see sort of like a little bunch of different particles that are all coming across horizontally. So then I think that also interacts with how I'm doing the like temporal filtering here. So some of the blurring here, the vertical blurring is just because I'm calculating it at a low resolution and then scaling it up. The horizontal blurring, and so actually the vertical blurring is something I wanted, but I didn't want it to look so chunky. Like this is an obvious linear interpolation. I wanted it to look like something a little classier, like maybe a cosine. So I was going to change that, but that also interacts with everything else here that I'm trying to change. So when I rewrite that, I'll rewrite it as a cosine instead of a linear interpolated rectangle. But then the horizontal blur here is coming from like an exponential decay kind of thing. So it's kind of like this whole waveform is being projected onto a phosphor screen that has some persistence. And it's tempting actually to just take that approach to the end of the pipeline, and instead of having that persistence apply to this one-dimensional data here, just do the persistence on that entire image, so that even if you change waveforms and stuff, that these kind of have a fading effect. And that might be nice. It seems like at the very least I want the persistence to include whatever two-dimensional data structure I'm storing the like coverage by wave map on, which could be either an image or like a floating point array, that I want that to have the persistence applied, because when I'm changing the number of active waves, I don't want the vertical changes to be super jarring. So a little bit of like temporal low pass filtering on that will, I think, help it be more visually pleasing. I guess the other thing I might work on is, or the other things on my to-do list at least, is that all of the tools on the import side of this for actually building these databases of grains, they could use more work. It's all really bare bones and slow and not efficient. I think the low-hanging fruit there really is to just have an additional chunking step so that I do the analysis on small pieces of the input files, so I don't have to keep large amounts of input data in memory, and so that I can do the analysis at a different sample rate than what I'm actually keeping. The TikTok voice stuff that I was doing, all of those came in at 24 kilohertz, so that was pretty close to what it made sense to do the analysis at anyway. It didn't really make sense to resample. But with some of these, I want to actually keep the original at whatever sample rate it's coming in at, like 48 kilohertz, but then also have like a lower rate mono signal for doing the analysis on. So I think I want to change that tool set a bit, so that maybe right now, maybe I just kind of change that whole thing. I've been kind of avoiding changing the tool set too much because I had a lot of data files that were in this intermediate format, the big numeric Python arrays, and I wanted to play with those data files. But I think now I'm just more interested in making it more efficient to ingest new data files. So I've done enough with the files I've got. So I might just make a new ingest tool that's kind of end-to-end, and maybe I make something that, I still kind of like having two steps. One, to just like let your CPU crunch on a bunch of audio files and scan it for features and figure out what's there. And then another more interactive step that's like blending that data into a particular data file that you can load into this tool. I kind of like those to be separate, but maybe the interchange format in between those, instead of being just like gobs of audio in NumPy arrays, they would just be just the feature data, and then we'll just decompress the audio files again in order to recompress the parts of it that we want as FLAC for the output file. Anyway, that's enough talking. thinking about the variable grain placement. I like the idea of adding another field to this grain sequence point that describes the time period of a grain. So the way I've modeled this, I've got a bunch of synthesizer voices that each play a train of overlapping grains that come in first in, first out queue. So within one voice, the grains can overlap an arbitrary amount, but they have to be in order and they have to use some of the same parameters, like the same window function. And what I'm trying to do is make it so that each individual grain within that queue can have a different timestamp rather than just being always at the same rate. I'm realizing this overlaps with another wart in my design here. So if I want to have, so I'm thinking about changing how the grain rate parameter is represented. Right now it's just one of these kind of free-floating parameters in the sound, which is our juice synthesizer sound. And that would need to become a parameter for the grain sequence. But I think this is exposing a problem where I do actually have some parameters that are common between the MIDI grain sequence and other kinds of grain sequences. So maybe I need to repartition how this works a little bit to make this less bad. So there's already the grain rate, which is outside here, and these gain parameters in the MIDI sequence that are actually really needed for the stationary sequence also. And stationary sequence is the one used for touch events. I want to test this out, but it should support multi-touch. I don't have any multi-touch capable devices right now set up to run this, but I want to try building this for Android and running it on a tablet. Phone, because you should be able to play the grain map with your fingers. Oh. That's right. I think speed warp is a parameter both for the maze sequencer and for the waveform window. Yeah, that turns into the speed ratio. Not the window, but the waveform key. This is like the information we use to look up a cached grain waveform. Pretty warm in here. Kind of tempting to move this whole param struct into the base class. Like, it kind of depends on whether I end up wanting the touch input to actually support the spread parameters. It seems like maybe they would be more useful if they did. So then that would make the pitch bend range and the cell mod and cell center MIDI specific parameters. And I guess I would rename that stuff that's in MIDI to like MIDI state, and I'd have MIDI state and MIDI parameters and then generic parameters. Let's just do that. Is there ever actually a reason? Oh no, this might be one of those design refactors that starts snowballing a little bit. I'm just wondering if this has me wondering why this doesn't include the speed ratio. should it not be possible for a grain sequence to change speed ratios while it's running? I guess originally I ended up at this point because I was trying to divide the responsibilities between the stuff that had to take part in grain sequence generation and the stuff that didn't. Remind myself how I construct the window function. Yeah, I feel like I need to rip out one of the layers here and simplify this a bit so that the sequencer is actually just returning a waveform key and a gain and a timestamp. And then it would actually know about the window and the grain rate. I'm hoping nobody in here actually needs to know the grain rate though. That would be a problem. Alright, so stuff like this would have to move to the sequencer. This is used to figure out how much to pre-fill the cue when a sound starts. I guess that's the only place we use it. That would be a reasonable question to ask the sequencer, like, how many things do you plan on producing per unit time? So that would be a pretty easy architecture change there. I guess this would sort of turn the grain sequence into kind of my internal object that represents a lot of what goes into figuring out what something sounds like. It would generate all the parameters for the individual grains that go into a cue in the voice. And then grain sound would become more like the glue between a subclass of that that's specialized for MIDI and the juice synthesizer itself. So the mouse input is more useful than I expected it to be, and I think it would help for that to respect all the spread parameters while still, not using the MIDI related parameters. feel like this question comes up all the time. Do I want to do something with samples or in a time unit? The answer is usually in samples, but I've got to make sure that that actually makes sense. I feel like this is one of those situations where I'm constantly redesigning a thing, and each iteration is the prototype for the next. Like, I don't have any idea what I'm doing here. I'm just trying to kind of scratch an itch to create something that I have wanted for a little while. I don't know at this point whether this is something that other people are going to want or whether it's just like going to be my own weird little experiment that I may or may not even use, like so many of these things. Yeah, like I've changed how the grain reservoir works so many times. I think the current system's actually kind of okay, although I feel like the thing it's mainly lacking is some kind of prioritized queuing on the loading end. So if it is backlogged, it still doesn't have anything extremely intelligent, but it at least has like a last in, first out queue now for the loader. So it'll try to keep up with new notes, even if it's got a backlog of stuff for like hungry background voices. I guess if I'm in the mood to do something demo-ish while I'm thinking about the architecture, I could try setting a MIDI file that we've had on this channel before. Oh gosh, every time I open this, I have to tell it the plugin's updated. Somehow I've got 2 copies of Ardor running. Hopefully that isn't a problem.
Sure, that's company.
Cherry.
Indemnity sponged into brings illness, king's join. Ferromagnetism flinches anomalously. Airings undamaged.
16 hinaufzusteigen. 11. ermissen.
Stargaze, feathering strong modelings, blushingly nappers age. Judges bobbing jabbers. It's tentacle Stratotheorus duplicate.
Hooks chain shelling egg. Hooks chain shelling egg. Hooks chain shelling egg. Hooks chain shelling egg.
Wird geschwänzelt, klein.
Zazen,
Squash common nuts.
Yoshos
Zu kassieren ich
Sasain
ist
Kongo,
Übernahmefieber
Shinto,
anzufahren, Millionen
Flammer redeemed yet
Personalizes
Tragen neues
Sain woven chummiest.
axon nagging.
Valence Capus,
Working ergonomically.
Ophelia Ranchers Valence.
Staged festivals. Beds. And now purge me, having repented ere the hour extreme.
Leave the nest and lets it downward droop. Even such was I.
Or Augustus, but poor
Thither
to
we
it
came,
that
and
of
thence
the
down
sun.
in the moat I saw people.
This is thou wouldst not want, words many to write, words many to
and
insist,
with the
thou
notch
wouldst not
backward
want,
upon his
words
jaw.
thou wast speaking Lombard, which someone here with me would
she has
fain
fed her
be
little
faster
ones,
from
and he who has been fed looks up.
On the left and a period on the right, depending on the light source. Depending on the light source. I'm going to add some sparkle depending on the light source.
Snow and then a little
that
shadow
and
of
not
the
giving
bank.
too many shadows. Got roots, so it was our viridian green.
A little bit of cad yellow, a little yellow ochre, a little bit of land that lives weed, Van Dyke brown, a little bit of cad yellow, a little yellow ochre, the edges a little, make great big ones or little ones, so we'll take this titanium white, come right across. Just sort of looks dark. Now then, with a clean, I just want to show you numerous layers in here.
Whatever fashion you put the trees in.
And we need some limbs on it. But you showed us at the beginning. But you
Just simply find that medium line.
We have to take care. Take care.
I'm using black next to your name. Let's take today. Take a little bit of
Just using red, no other color, just plain red.
Don't worry about what's behind it.
I would recommend coming up to
Dark sienna, red, so I'm going to go right into a small touch. Just do enough cad
Handle the
layers.
background with
Very
this, and
pretty.
I'm just
You can
going to
see
let
the
the brush dance to it.
I guess ardor crashing on exit is just a thing now. May or may not be my fault. That's mostly what I'm changing, right? I use this like in 2 places. So yeah, I think if we do this where every queue entry has a timestamp offset in samples for the next grain, that'll match up pretty closely to what we're already doing. Oh, there's a question about what the color bands were. It was pretty much an arbitrary color scheme, but it maps to the position of the grain data within the file. So that's, again, pretty arbitrary, but depending on the data set, it could have some meaning. So like in the TikTok data, that maps to the different TikTok voices. And like for some of the audiobooks, they're different chapters or different books. So that's something else that I want to make a little easier to define in the processing tools. Because right now it's just something you have to define by like the order that you pass the files to the packing tool. And it would be nice if there's something more explicit. That could even be an additional sorting step. So maybe there's a way to sort them by like some kind of harmonic quality, or I'm also maybe interested in pre-processing where we search for just like I'm thinking about some measure of like audio quality or noisiness or something, because it'd be nice to have a way to distinguish between stuff that's like closer to a pure tone and stuff that has more like spread spectrum noise. And so if there's a metric we can choose that captures some of that and then sort the samples by that, that might make a nice y-axis. So yeah, right now it's pretty arbitrary. I've been calling it the selector axis. There's pitch on X and selector on Y, and it's really just which grain within a pitch bin we're choosing. You may be wondering why I can't just change the value of this function. That would certainly be one way to change the repeat rate. The issue is that if I just changed it at one time, that would cause an audio glitch, because it wouldn't be changing, it wouldn't be changing the boundary between 2 grains. It would be changing the grain rate that we're using to generate the audio between 2 adjacent samples. So it would generate like a little click there. I guess another way to describe it is that once we've started playing any particular grain, we can't change its parameters. Even though we're not like explicitly storing the grains that we're playing, we have to make sure that they're all like processed from this queue without changing the queue once we've started a particular grain. We can make modifications to the queue ahead of where we're playing from. There are a couple of places we do that to manage latency. Yeah, that's what this num active grains is for. Yeah. Let's see if there's a big. Well, I might keep this stream kind of short. I think I've got a lot more energy for coding today than I have for being on stream. But it was nice to hang out for a minute. Have a good weekend, everyone. I will see you next time.